Okay, so we can start discussing the questions of the contest. So today's contest was amazing and a little bit easy also. Okay, so we will discuss the first question: count elements with strictly smaller and greater elements. So what you have to do, you have to find all the elements which has greater, strictly greater and strictly smaller elements. Some elements should be there, right? For example, if you have this array nums, then there should be some element for 11 which is strictly greater than 11, and strictly, and some should element should be there which is strictly smaller, and you can find it. 15 is strictly greater and 2 and 7 is strictly smaller than 11, so it will be counted. Okay, and what about 7? 7 also have one strictly smaller and two strictly greater, but 2 doesn't have. 2 is the smallest one, right? So it doesn't have. So if you will sort it like this: 2, 7, 11, 15, you will see that first element, last element will not have strictly greater and smaller. All other elements in between will have, but you have to check one edge condition, that if this kind of thing will come, then what you will do, means two twos are coming, so this will also not have strictly small and greater. So what you have to do, start from first point and start increasing till the point where when it is equal, means all the twos are coming, and do the same thing from here last, and remove those element, and remaining elements are having the strictly increasing and strictly decreasing. You can do that. So that's the solution for the first problem. This was an easy one, and now I will discuss the second problem. So this is the second problem. Okay, so what we have to do, we have to rearrange array elements by their sign. So this is an array, right? And you have to rearrange by their sign, and you have to maintain the order also. For example, 3, 1, -2, -5, 2, 4 is coming. So what you have to do, 3 should come. After that, a negative sign element should come, but order is also maintained. So first negative you will take, then the next positive will come, then next negative is -5, next negative will come, then next positive is 2, 2 will come, then next negative -4 will come. So this is the order which you have to return. You can use two approaches. One is, of course, 2-pointer approach. You can make one pointer for positives and one pointer for negatives, and whenever there's a positive element which is not in the correct location, you can stop there, and whenever you find a negative element which is not in their right location, stop there and swap it. This is the first approach, but I will explain the easy one also. So what you can do, you can create, you can use extra space, create the half size array. Okay, for positive, half size array for negative, and means half size. What I'm trying to say, if there are 6 elements, create the array of 3 element, and what you will do, whenever a positive element is coming, store in that array. So one array you are creating num pos, another array you are creating num negative, and whenever positive element is coming, store in this. Whenever negative element is coming, it's stored in this. You can create a list also. And what you have to do, simple: pick one element from here, second from here, one from here, second from here. Simple. There is a simple approach, right? So this is the solution for second problem. Now we will jump to third problem. And what is third problem? So in third problem, we have to find the lonely numbers in this particular array. So what is the definition of lonely number? Lonely number is the number which is coming only once in this array. First property. Second property, if the lonely number is x, then x plus 1 and x minus 1 should not be in the array. So for example, 10 is coming only once in this array, and 11 and 9 is not there in this array. So that's why 10 is lonely. Same for the 8. 6 and 5 is not lonely because 6 minus 1, which is 5, is there in the array. So these type of numbers you have to check. So what you can do, you can create a hash map, right? Where you will store the integers and their count. So this is one of the approach. You can save the space in another approaches, but I will use hash map for simplicity and maintaining the integer and its count. So iterate once. If integer is not present, add it in the hash map, and if integer is present, then increase its count. And in the next iteration, what you can do, So you will use this hash map in two ways. So in next iteration, what you will do, for example, you are in 10, and in hash map, what will happen? You will store 10 one time is coming, 6 one time coming, 5 one time coming, 8 one time coming, right? So this is your hash map after one iteration. In the second iteration, you will check if 10 is there, you will check how many occurrences are there of 10. If more than one is there, leave it. If one is there, then next condition you have to check. Is 9 is present in the hash map? No, it's not present. Is 11 present in the hash map? No, not present. If not present, add it to your answer list, this particular 10. So the same thing you will do for 6, 5, and 8. So this is a simple solution for this problem. And so this I did, like I created a hash map. So in one iteration, I just updated the hash map. In the second iteration, I'm checking if its count is 1, then only go inside and check if more plus 1, x plus 1, and x minus 1 is there or not. If it's not there, then add it to our answer list. So this is the solution for third problem. Now I will jump to the last one, and last one is maximum good people based on the statements. Okay, this is interesting, and it took the most of my time. So I'll explain it. So what you have to do, so if this there is an statements, right? So I will explain the question first. So what's there? There are two types of person. One is good, another one is bad. And the property of good is he will always tell the truth, always. And bad person can tell the truth as well as lie. It can be anything. All right. So what you have to do, there are some statements. So zero means zero means if this person's index is 0 and this person's index is 1, and in statement 0, 0 1, 0th row and 1th column, if for example if 0 is there, then this person is saying that he is a bad person, this one. And if that value is 1, then he's saying that he's a good person. And if that value is 2, he's saying nothing, no statement. Okay, so what you can do in this, first thing you have to, like when you are giving a contest, you have to check this thing where it is constraint, and you can clearly see that n is only 15. So there should be something like very, like you can say backtracking type of approaches should be there, which will go for all type of combination, because n is 15 only, right? So what I did, I created all type of combination in this, and I checked for those combinations which are not correct. So this thing I will explain what I am trying to say. Okay, so what I will do, if there are only 3 people, right? So how many combinations are there? All are good, all are bad. So I think 2 to power 3 combinations are there. So 8 combinations are there, like this. Like this is good, then this is also good, this is bad, this is good, this is bad, this is good. So these kind of 8 combination will come, right? Now you have to check which combinations are the possibilities, right? For example, this is this possible? For example, in this, if I will take the first example, so what's happening here? 1 2 2 and 2 0 2. If I will say all are good, right? So all will tell the truth, but third person is saying that second person is bad. So if he's telling the truth, how it's possible, right? He's a good person because everyone is a good person, and he's saying that second person is bad, and he's telling the truth. Getting the point? It's not possible. So this combination is not possible. So what you have to check, because bad people can say anything, truth or lie. So don't worry about what bad persons are saying. Just leave them. Worry about the good persons. If you are saying that someone is good, then whatever he's telling, you should believe him. For example, in this particular question, like if you will take this example, I will give you simple example. This first person is good, all other persons are bad. If first person is good and he's saying that second person is also a good person, and you are assuming that first person is good, but you are saying no, he's bad in your assumption, right? So this is not a possibility. So in the same way, you will check for the cases, right? All the cases, and whenever some possible combinations are passing your means this check, then you will check for the total of good person in your assumption. For example, this is passing your check. So what you will check, like how many G's are there, means how many goods are there, and you will maintain some max for that. Like if two G's are there, then you will update your max to two. If somewhere in some combination 3Gs are also a good combination, then you will update your max to 3. So in max you will get the maximum number of goods, right? So this is the thing I am doing. I will explain the code also for simplicity, and you will understand. And remember this thing, always worry about good persons, what good person is saying. If you are assuming someone is good, then whatever he is saying, you have to check if that is correct in the assumption or not. So that's the concept of this particular problem. So what I'm doing here, I'm creating a combination. So all the combination I'm creating here. So for creation of combination, I created one array, character array, and like this is a very generic way of creating. So this is a tree based creation, right? That will also explain. So if I have in first index, I have two choices, either G or bad. Then in second index, again I have two choices, G and bad. Here also G and bad, right? So the same thing I'm doing. For every index, I have two choices, G and bad, and I will go for the next index. Then again, it's calling the same function. Again, I have two choices. And when our index will reach to n, means all the choices are done, I will check. Check function is called, that it is a correct combination or not. So that I will do, right? And in check function, what I'm doing, if someone is G, if someone is good, then whatever he is saying should be right. Otherwise, I will return false. Means this is not a good combination, right? So this check I am doing here. And if this check is approving, means it's a good combination, then I'm checking how many G's are there. If it's more than my maximum, I'm updating my maximum. And the last I'm returning the max. So this is the solution. And it was an amazing contest. And if you have any doubt, please ask me. I will definitely help. I will try to help. Please ask me in the comments, and keep coding.